Enough with all the basic stuff already. Let's get on to building our first project. I hear you, we're going to do just that. Our first project is controlling an LED using the Arduino. It seems like a simple project, but if you are new to Arduino, it's a great start in understanding how your hardware and software plays together in Arduino land. Let's take a look at the objectives for this project. By successfully completing the project, we will have mastered the following items. You'll understand how an LED works, how to wire an LED in a circuit, and we'll learn how to use the pin mode, digital write, and delay functions. These functions are very common in a lot of our projects. Let's get the show on the road. Here are the parts that we will need: an Arduino Uno, a USB cable, a breadboard, a red LED or any other color of LED that you might have, a 220 ohm resistor, and connecting wires. Let's first address some basics about an LED. LED is short for light emitting diode. In the world of electronics, a diode is a device that conducts electricity in one direction only. This is the case with an LED. It has a long pin, which is referred to as an anode, and a shorter pin, which is referred to as a cathode. When we apply an electric current to an LED, current flows into the anode and out the cathode. So here, the current is going to flow into the anode and out the cathode. Generally, we also connect a current limiting resistor in series with an LED. In that way, for a given voltage, we can limit the current flowing through the LED so that we do not burn it out. So in this circuit diagram, our DC voltage is applied, and from the positive goes into the anode, out the cathode, through our current limiting resistor, and back to the DC power supply or DC voltage. Now that we have those LED basics down, let's take a look at the circuit diagram for our project. It's very simple. First, we have from the Arduino, we have the ground pin connected to the ground rail. Then we have the 220 ohm resistor going to our cathode of our LED, the negative pin or shorter pin of the LED. And then from the anode or the longer pin, we have that connected to pin 8 on the Arduino. Very simple, very straightforward connections. Let's wire up our circuit. First, we're going to connect our LED. Then we have our current limiting resistor going from the cathode to ground. Then I'm going to connect the ground rail to the ground on the Arduino. I could have also directly connected the resistor to the ground pin on the Arduino to save a connecting wire. Next, from the anode of the diode, I'm going to make a connection to pin 8 on the Arduino. And that completes our wiring. Now we're going to go ahead and upload the code. Right, there it goes. So as you can see, our LED is blinking on and off. Yay, success! You have wired up and created your first Arduino project. Let's take a look at our code. Essentially, at the top of the program, we define our LED pin as 8. So remember, we did connect the anode to pin 8 on the Arduino. Next, in our setup function, we use the pin mode function to determine or specify that the LED pin is going to be an output. So pin mode tells if a pin is going to be used as an input or an output. It takes 2 arguments to this function. The first argument is the pin, which we define as pin 8, and then The second argument is whether it's going to be an input or an output. So our setup function is very simple here in our first program. In our loop function, first we do a digital write to our LED pin, turning it high. So that's going to turn the LED on. We then use the delay function, and the delay takes the number of milliseconds as an argument for our program to halt or stop. So when we do delay 1000 millisecond, it pauses for 1 second, or the LED stays lit for 1 second. Then we proceed to turn the LED off. So we do a digital write to the LED pin, setting it low. This turns our LED off, and again we wait 1 second. So we do a delay 1000, we wait 1 second, and then our loop function starts all over again. We do a digital write, setting it high, wait 1 second, then a low, and wait another second, and so on. So as long as power is applied to the LED, this will continue looping and our LED will be blinking on and off. So let's take a look at our pin mode function. In the documentation, as I mentioned, pin mode takes 2 arguments. Pin is the number of the pin you wish to set, and then mode is whether it's an input or an output. In another lesson, we'll look at input pull-up and exactly what it is. It's an input pull-up resistor, but for now, input and output determines if the pin is an input or an output. The other function that we looked at was digital write. I'm going to link to that here. And digital write, again, takes 2 values. The first one is pin, the pin that we want to write to, and then the other argument is the value, whether it's high or low. So again, it is used to turn our LED on and off. The final function that we looked at was the delay function. I'll bring that up here. And delay, as I had mentioned, takes the argument is in milliseconds. So it takes the number of milliseconds to halt or delay your program. And when you do delay 1000 milliseconds is 1 second. So we just pause for 1 second. That's how we're able to keep our LED on for 1, off for 1, and so forth, and it keeps repeating. So those are the 3 functions we were introduced to in our first project. To summarize, in this project you learned what an LED is and how to connect it in a circuit. You were also introduced to the concept of how your code is uploaded to the Arduino. The pin mode, digital write, and delay functions were also introduced to you, and you should have now be aware of how to use them. These functions are the building blocks of many Arduino projects, so it was great that we got them covered here. Let's move on to our next lesson.